stoichiometry is actually all about ratios. A lot in physical science, a lot in life is about ratios. So we have to understand ratios to be able to succeed in solving stoichiometry and many other problems. So what are ratios? A ratio is a relationship between two or more things. What do I mean by that? Let's take this example. We have girls here and shoes here, and then here we have girls with shoes. Now it's important to understand the difference between actual amounts and ratios. So let's speak about the actual amounts of shoes, girls, and girls with shoes that we have, and then the ratio of these three to one another. So the actual amounts are 2, 4, 6, 8, 10, 12 shoes and 2, 4, 6 girls, which then gives us 6 girls with shoes on. But now let's speak about ratio. Ratio refers to the comparison between the things. How many shoes per how many girls? And of course you need 2 shoes for each girl, for one girl. And that will give us 1 girl with shoes on. So notice that this is the simplest way of writing the possibilities of the relationship between girls and shoes so that each one gets shoes on their feet, on both of their feet. 2 is to 1 is to 1. 2 shoes for every 1 girl to give 1 girl with shoes on. That's a ratio. But we can have any multiple of that in actual amounts. In this particular case, we have 6 times that. We have 6 girls, and so we need 6 times 2, 12 shoes. And that gives us, after they've put the shoes on, 6 girls with shoes. So everything here is multiplied by 6 from the basic ratio to give this particular situation how many girls and how many shoes. We could have had a different situation. Maybe these 2 girls weren't there. Then we wouldn't need these 2 pairs of shoes, these 4 shoes. Then we would have had 8 shoes for 4 girls, giving us 4 girls with shoes on. This is still in the same ratio of 2 is to 1 is to 1. It's just now 4 times more than that basic ratio. So this particular actual amount is 4 times the basic ratio. And we can have infinite other possible actual amounts which all fall within the same ratio. So let's answer some simple questions about these girls and these shoes. And for these questions, we'll assume that all the shoes have a mass of 0.2 kilograms per shoe. And every girl is identical, which is obviously impossible, but just to make it simple, and every girl has a mass of 50 kilograms. So our ratio is 2 shoes for every 1 girl gives 1 girl with shoes on. We can call this a particle ratio because girls are particles. They are objects, so they are particles, and so are shoes. And so are girls with shoes on. So the particle ratio is 2 shoes for every 1 girl for every 1 girl with shoes on at the end. Now let's convert that into a mass ratio. So what is the mass of 2 shoes? Each shoe has a mass of 0.2 kilograms. So 2 of them together have a mass of 0.4 kilograms. 1 girl has a mass of 1 times 50 kilograms, which is obviously 50 kilograms. And 1 girl with shoes on has a mass of 50 kilograms for the girl, plus 0.2 for each of the shoes, and there are 2 shoes, so that's 0.4. Notice that mass has not been created or destroyed. This is the mass that we have at the beginning when we have 2 shoes and 1 girl. And then the girls put the shoes on. There's still just as much matter as before. It's just rearranged. Before the shoes were off the feet, now they're on the feet. So obviously the combined mass here must be the same as before the shoes were put on the feet. And it is 50,4 is 50 plus 0.4, of course. So this is a mass ratio. 0.4 kilograms of shoes is to 50 kilograms of girls is to 50,4 kilograms of girls with shoes on. We can use these ratios to solve problems because if we know the ratio, then we can apply that ratio to any particular actual amount situation, because any particular actual amount is just a factor of the basic ratio. So let's answer this question. How many shoes are needed for 5 girls so that each girl will have a pair of shoes on her feet? So this is our question. We must multiply it by a conversion factor. This conversion factor needs girls at the bottom to cancel that unit away and shoes at the top. And then we need to make sure that this conversion factor here refers to equivalent amounts for this particular reaction. Now, we don't normally call girls putting shoes on a reaction. We'd call it getting dressed. But just to make it similar to chemistry, let's say this getting dressed is a reaction. So during this reaction, this getting dressed, of course, every one girl needs to put on 2 shoes. That's the normal ratio in which they react, in which they get dressed. So 5 times 2 divided by 1 is obviously 10 shoes. And you should see that actually this is so obvious you didn't need to do a method. I mean, obviously, how many shoes must 5 girls have? Obviously, they must have 10 shoes. They must have double as many as they are because they need 2 shoes for each girl. But it's good to take an easy situation and use the method so that we can get used to the method and apply it to more difficult problems. How many girls can put 2 kilograms of shoes? Of course, not any shoes, but for this particular situation, these shoes on their feet. So we need a conversion factor which has kilograms of shoes, for these particular shoes, of course, at the bottom, to cancel that unit away, and girls, again, these particular girls, at the top. So now we need to use a particle mass ratio. So we're interested in the mass of the shoes of the basic ratio and the number of the girls. This is not kilograms girls, it's girls, the number of the girls for the basic ratio. Remember, these two are both ratios for the reaction, the getting dressed, of girls and shoes. And the ratios of the reaction give us the conversion factor. So we know that 0,4 kilograms of shoes is the mass of shoes needed for one girl to get dressed in this situation. So they are equivalent for this reaction, for this getting dressed. One girl needs 0,4 kilograms of these shoes, and then she will have 2 shoes, one for each foot. 2 divided by 0,4 is 5 girls. 5 girls can put 2 kilograms of shoes on. Now, there are other ways to answer this. For example, you know that 2 kilograms must be 10 shoes, because each shoe has a mass of 0,2 kilograms. So 10 of them have a mass of 2 kilograms. And 10 shoes obviously fit 5 girls, because 10 shoes is 5 pairs of shoes. So you could have done it that way without this method that I've given here. But in this case, it's easy just to think about it, which is excellent. You should try do that. Think about it logically. But sometimes it becomes a bit more difficult, and then you need a method. And it's a bit difficult to just think about it logically, although you should always try. What mass of these shoes? How many kilograms of these shoes? It's important to write kilograms of what, not just kilograms, otherwise you're going to get confused. Is needed for 250 kilograms of these girls. Again, don't just write kilograms, because then you'll get confused. Are you speaking about of girls or of shoes? So that they have shoes on. So we need a conversion factor with kilograms of girls at the bottom to cancel kilograms of girls away. Do you see how important it is that we do specify kilogram of what? Otherwise we wouldn't have known that we could cancel that. And kilogram of shoes at the top. So now I need a mass ratio. So you see, actually here we have actual amounts for this particular question. We're given a particular amount for this situation, not the general ratio situation. This particular situation, we have 250 kilograms of girls, and we're asked for this particular situation how many kilograms, the actual amount of kilograms of shoes for this particular situation. And as our conversion factor, we use the ratio, and in this case it needs to be a mass, a kilogram, a mass ratio, which is the basic proportion in which they always get dressed, react. that. And we know that it's 0,4 kilograms for every 50 kilograms of girls. 0,4 kilograms of shoes for every 50 kilograms of girls. That is the ratio in which they always get dressed, these particular girls and shoes. 250 multiplied by 0.4 divided by 50 is equal to 2 kilograms of shoes. Again, we could have just thought about it logically. 250 kilograms of girls is 5 girls, and 5 girls need 10 shoes, each shoe being 0,2 kilograms in mass, so that's 2 kilograms of shoes.